Good afternoon, everybody, and welcome to today's ANZ Lunch and Learn seminar on moving classic and emerging ASP.NET applications into AWS. And we're going to do it one Docker container at a time. Hi, I'm Peter Stansky, also known as Dr. Pete, and with me I have
Daniel Zoltak,
who's also an AWS Solutions Architect. So today we're going to walk you through a journey of moving your .NET workloads, both classic and greenfields, into AWS. So the brief agenda for today is we're going to cover off a little bit around the history of Microsoft and the .NET runtime and how it's evolved over the years, and what Microsoft's been doing around emerging that technology into the open source community and opening out for everybody to use. We're also going to focus on how the developer experience may have changed and how that actually has been re-engineered for doing work outside of core Windows OS development environments. We're also going to demystify .NET Docker and what the containers actually are. So today is going to be also hands-on. We're going to show demos and we're going to go beyond the slideware and actually show you how to work with Docker and how to use .NET applications to get you there. And as a part of that, we're going to walk you through what AWS has in store in terms of support on taking and assisting you on the cloud journey with your existing tools into the AWS environment. So let's talk about Microsoft.NET. For those of you that have been around for a while, you may actually remember it was called the Common Language Runtime as well. So think of it as back in around circa 2000, Microsoft released the .NET framework. When it actually shipped, it shipped with over 20 different programming languages. In other words, this was the next generation of virtual machines that would be able to take multiple different programming language called the Common Language Runtime, and all of these programming languages could be compiled to run on a single unified framework. So whether that was Pascal, whether it was Haskell, even COBOL, and those other traditional languages like VB, .NET and C#, and also J#/Java also made their way to the .NET runtime. And the idea of the .NET runtime was to be the next generation runtime, which also made developers' life easier on the Windows platform. If you ever had to build Microsoft applications on Windows, and this was around that time, you possibly would have been writing them in C or C++ using the Win32 API. You also would have been, hopefully, would have learned what COM stands for, which is the component object model, which was something else you had to learn in order to be able to deliver quality applications on Windows. All of this stuff was really a black art for building software. So it was really convoluted, really difficult, and what .NET brought to the table was a much simpler, much more abstracted, much more current environment for developers to be able to build rapid applications and have them deployed not just on the desktop, not the server, and not just devices, but a whole unified experience. And all of this was wrapped up in Visual Studio.NET, which was the development environment which is fully integrated to allow the developer to build applications really rapidly on the Windows operating environment. Microsoft also very early on realized that they had to standardize .NET in order to make it successful. So very early on, they approached the European Computer Machinery Association to standardize the .NET libraries and the runtime. And they also released a shared source version called Rota. So the shared source approach was, it wasn't open source, it was actually closed to certain use cases, which meant that you couldn't use the runtime for anything other than academic or exploratory purposes. You could use it commercially. So this didn't get very far, but it did actually allow a lot of universities and a lot of language researchers to be able to play with the platform. So they codenamed this Rota. Rota was quite successful, but again, it was only successful within a very small community. Having said that, a couple of really clever engineers had a closer look at that and went, hey, we could potentially develop this. Because Rota was at that point cross-platform, you could actually run it under BSD, Linux. They thought, wouldn't it be great if we could take all the great things that the .NET runtime does and move it into a Linux and maybe even an OS X platform. So hence Mono was born. It was a great idea of rebuilding the actual platform, and it made its way into the open source community, followed by it being evolved into being able to develop applications not just on Linux and on Windows or the Mac OS, but they also released Mono Touch, which then took Mono to the next level, which allowed developers to also develop mobile applications on both Android and the Apple iOS platform. They've also added a great deal of support into Visual Studio. They had their own IDE called MonoDevelop, which was also integrated with Xcode for those working on the Mac platform. And eventually, this company called Xamarin has now, in 2016, been acquired by Microsoft. So as you can see, there's been a great deal of open source ingestion into the Microsoft organization, which allows developers to benefit from that. On the open source efforts from Microsoft, for those that have been paying attention, you may have come across something called Roslyn. Now, Roslyn's set of tools is, again, another open source initiative from Microsoft to allow to open up the .NET compiler platform tools for other people to build upon. So this essentially is a set of compilers and code analyzers and APIs that actually lets people build on top of the C# and VB.NET compiler to allow them to reflect and better understand all the bits that are hidden away from most developers, which are in the realm of compiler developers. And that's a very important initiative because that actually now allows other open source communities to take the .NET language and the runtime and do some amazing things with it. So having said that, around the same time, Microsoft decided to go full open source with the .NET runtime. And they announced something called the .NET Core, which is a much more streamlined, much more modularized, common language runtime that's available across multiple platforms. They also evolved the .NET application components and assemblies. They've also evolved ASP.NET, which they called ASP.NET vNext. Or for those of you that have been paying attention, again, it's called ASP.NET 5 and 6. And again, more recently, they've announced support for Microsoft Windows and Docker, which is, again, another big step towards being very open, because Docker's been around for quite a while in the open source Linux community. Microsoft, just like AWS, have made a commitment to working very closely with the Docker community to allow applications to be containerized and to be made more available for being able to run cross-platform. More on that later. And finally, something else to make you aware of, Microsoft has also created a .NET Foundation. And this is a community that supports the open source initiatives to be able to take all of the open source projects in relation to Microsoft.NET and the runtime environments and take them to the next level. So, as I mentioned before, Visual Studio and the Microsoft operating system is the premier development environment for users. Microsoft has also been paying attention and having a closer look at how do people build software. And a lot of software development is done through automation, which often ends up being done at the command line. So as Microsoft's been evolving its tools and its command line approach, they've also provided now greater support for having command line tools that will let you compile, update, and deploy your application. So you're not just doing it from the Visual Studio GUI front end by clicking on buttons and going through wizards. You can essentially have the same functionality available to you from the command line, which now means that with the release and moving towards ASP.NET Core and ASP.NET vNext, you can now have a very similar experience that you would have had on the Windows platform on a Linux or a Mac OS experience. So developers can use tools like Visual Studio Code, which is a very much a smaller version of the Visual Studio IDE, which run on both Linux and the Mac. Or perhaps you can use other third-party editors like Sublime, Emacs, all of which can now also use IntelliSense. And IntelliSense is the pop-up context additional information that you normally get in your editor to be able to prompt the developer with additional information about the code they're trying to write. So all this is available open source. And if you visit omnisharp.net, you'll be able to download some tools that plug into those editors in order to give you things like IntelliSense. So just to recap, this is a very big step for Microsoft because traditionally this has been a Windows-centric, Visual Studio-only mode of developing software. So the command line experience now being identical across Windows, OS X, and the Linux variants, you can now integrate your application development much more tightly into continuous integration and delivery mechanisms. You can build your deployment pipelines fully scripted and allow yourselves to be able to take, from check-in of your application into a source repository to activate a whole bunch of automated scripts and steps that allow you to deploy software very, very rapidly. The kind of stuff a lot of folks have been doing in the open source community for quite some time. So here's an example of this is what Visual Studio Code on the Mac would look like. So I'm going to let Dan hop in now and take us through building an ASP.NET application on a Mac operating system. And he's going to actually show us some of the command tools, as well as show you what Visual Studio Code looks like, which is what we're currently showing. So Dan, over to you.
Okay, let's take a look at the tools we can use to deploy an ASP.NET web application. So the first tool is Yeoman, and Yeoman generates out scaffolding for web applications. Yeoman is a Node.js application and can be installed using the Node package manager using the Yo package. So let's go over to our terminal and use Yeoman and the ASP.NET generator to generate out a basic web application project. As you can see, Yeoman provides different project types, console application right through to class libraries. So let's go and select the basic web application. It allows us to name it. We'll use the default web application basic, and you can see that Yeoman has generated out all the scaffolding. So let's go over to Visual Studio Code and have a look at what it's generated. So as you can see, on the left-hand side, we have our file view. We can see that it's generated out controllers. And if we click on that file, you can see the syntax highlighting, then the views, the web root, and a Docker file and some JSON files. So let's take a look at the project.json file. In here, you can see that it lists all the dependencies that are required to run the project, and it also provides some information on how to run that project. So here it's a web project and it requires the Kestrel web server. So let's go back to our terminal and cd into the web application basic folder and use the .NET update tool to restore all the packages that are required to run the web application. As you can see, we're using the Mono runtime for this demonstration. So once the packages have been restored, we can then use the .NET execution environment, so DNX, to run the web application. So we type DNX web to do that. So once Kestrel's loaded, it provides the port the local port to access the web application on. So here it's port 5000. So let's go over to our web browser and visit port 5000 on the local host. And here you can see the basic ASP.NET 5 web application. If we go back to the console, we can see Kestrel's outputting information. So information about the different content that it's serving out. So here we can see that it's invoked the controller and it's served out some static content such as PNGs and JavaScript. So let's break out of the web server and take a look at another tool called the .NET Version Manager. And the .NET Version Manager allows us to manage different .NET runtimes on our system. So let's take a look at what we have running here. So we can see that Mono is the default. So let's switch and use the core CLR instead. So select the version and the runtime is core CLR. You can see that's been updated in our local path. So if we then list the various runtimes, we can see core CLR is now the default. And if we use the execution environment again, it'll now use the core CLR rather than the Mono runtime to run our web application. So let's now go back to our web browser and visit port 5000. And as you can see, if we go back, it's invoking the controller and then serving out the various static assets. And now our website's up and running on core CLR. So let's do the same on Windows. So over here, I've got a running Windows 2000 R2 instance running on EC2. Let's open a PowerShell command line and use .NET Version Manager, and let's list the available runtimes. So currently we don't have a default, so let's use Core CLR x86-64. Under the Core CLR, you can see it's updated the path. So now let's just take a look and see if it's our default, which it is. Now we can use Yeoman and the ASP.NET generator to create a basic web application. So it's putting it again in web application basic folder. It's generated out the scaffolding. Let's cd into that folder and do a DNU restore to restore the dependencies. So that's just going through and doing that. It's reading the project.json file. You can see we're using Core CLR as our runtime. And then we'll use the .NET execution environment to start the web application on the local server. So let's bring up our web browser and go to the local host port 5000. So you can see that the web app's loaded, and if we just take a look at the console, you can see that it's outputted information about the different assets that have been served up. So as you can see, that the latest .NET tools provide a consistent developer experience across OS X, Linux, and Windows.
Thanks, Dan. It's great to see that Microsoft developers can now have the same command line development experience across multiple platforms like Windows, Mac OS, and Linux as well. So moving right along, we've already touched upon this briefly in a demonstration when Daniel showed the dnvm command, which is the .NET Version Manager. On the Windows side, you would have seen the classic .NET framework, which is running, and the one that you've been using for many, many years. And you also would have seen the .NET Core runtime. Now this is currently available cross-platform, as opposed to Classic, which is very much a Windows-only framework. In the .NET Core, this is pretty much currently in RC1 and heading towards release candidate 2, which now means it's finally in stabilization phase. Microsoft recently announced that you can now have a Go Live license, which means you can now use the .NET Core with ASP5 in production. And at the moment, it's being supported across Ubuntu, CentOS, FreeBSD, Mac, and SUSE, as well as Windows. If you would like to know more about what's available under the hood, Microsoft has open sourced this, as I mentioned earlier. So if you head over to GitHub, to .NET and Core CLR, you'll be able to clone and have a closer inspection of the actual source code underneath what's behind the runtime. On the Linux demo, which you saw earlier, Dan also had the Mono runtime available to him. By the way, Mono can also be made to run on Windows. So essentially, you can very quickly swap between the various frameworks and runtimes that you're working towards. But just be aware of the fact that some of these core runtimes support different assemblies and different libraries on those platforms. So what does that mean for you? Well, if you happen to be using Visual Studio, you may actually be experiencing this kind of an overloaded bit of IntelliSense, which gives you some indication that the string writer file class is actually not available on Core 5, but on 5 and 4.5 frameworks. So this is where it becomes very interesting, because now developers have to be more aware of the kind of code they're writing, because some of those assemblies may not be available on the target runtime. Having said that, if you are going to be focusing on the Windows platform, you can continue to use the same applications you have and assemblies as you have in the past. But if you are going to venture into the .NET 5.0 ASP runtime environment and you are going to go cross-platform, certainly pay attention to some of the warnings you're going to get at compile and development times. So what's the difference between the various runtimes, and what has .NET Core got to do with all of this? And fundamentally, why should you care? Essentially, when you look at the traditional Microsoft applications in the runtime support that you were getting, so for example, if you were to build my app, which has everything in it, you potentially be compiling it into a single DLL. You would then be dependent upon external dependencies such as System Web and System Core. And traditionally in the past, these have been very large assemblies, which has meant that Microsoft had to, recompile the entire assembly because, for example, system.web, that assembly may contain additional frameworks and additional systems, such as system core IO, system file, as well as under the web, you might have seen Signal IR or session. All of these now in the core runtime and ASP5 have been broken down into much, much smaller packages. And the idea is that instead of building large monolithic single DLL or couple of DLL applications, there's now a big move to use NuGet packages. And for those of you who've used NuGet, these are essentially self-contained application components that you can reuse and rapidly import into your application. So now when you do a build in .NET Core, the command line tools, the DNU tool, which is a .NET Updater, will actually produce you a NuGet package for your application. So what's the difference? In summary, Microsoft has decided now to reduce the packages to the smallest package sizes available, which means that they, including you, can now very rapidly iterate between different versions of system components that make up your applications. Instead of building from very large dependencies, you now build your applications from much smaller packages. As an example of that, if you head over to GitHub for ASP.NET, you will find there are at least 60 different projects that make up ASP.NET these days. So all of these can be pulled in or excluded depending upon your requirements of your application. Now, Docker. This is a very popular topic for everybody. Microsoft, like AWS, has made a commitment to the open source community some time ago to support Docker. What Docker essentially is it's a way of packaging your applications. So let me explain the difference first. So how is Docker different from virtual machines? On your left here, for example, if you look at a virtual machine running on top of a hypervisor, the virtual machine is potentially a very large VMDK or a very large file that consists of the entire guest operating system, any associated binaries and libs and anything else required for your application to execute. Contrary to that, a Docker image, in fact, is a much, much lighter weight application. Essentially what it means is you package your application and the runtime dependencies together, which means these are much more lightweight. They're highly portable because the Docker engine, like I said earlier, is now available not just on Windows, but also on Linux. So you now have the ability to be able to take your applications and run them across operating systems. So a little bit more about containers. So when you think about a container, it simply contains all of the application components and its dependencies. Quite often developers build their applications on a local development machine. They compile the app and they ship it over onto the server or pass it on to somebody else potentially. And the app may, most likely, for the first time you do this, break because there are potentially additional dependencies in the environment or the operating system that are dependent on to execute. So by running your application and packaging them into a container, the container can contain all of the additional dependencies, which makes life a little bit easier. Containers also share the kernel. In other words, they have very lightweight processes which are isolated from each other within the operating system. So you can run multiple Docker containers side by side, which will not interfere with each other. The operating system and the runtime environment will isolate these, which means that things like DLL hell, which traditionally have been a real big problem for a lot of developers, and being able to multi-tenant applications that share core OS dependencies, all those things have been challenging. Now you can actually get away from that. And because Docker isn't tied to any particular infrastructure, you can build Docker containers both on your laptop, on your development machines, and move them very quickly into the AWS cloud. Now, when you think about Docker, people often think about it on Linux. Because they are now supported on the Windows environment, we can thank Microsoft for opening up and supporting the open source community to allow greater cross-platform execution of your applications. So, why does it matter to you and for your applications? So, we've talked about .NET and its evolution, as well as the idea of now putting those applications in containers. So for existing applications, stuff that you've built many, many years ago, you are able to take these applications, package them into a self-contained environment, aka the Docker container, and then be able to run these using Mono or potentially .NET Core on different operating systems. So you can now extend the life of your apps merely beyond just a platform they were built on. You can certainly, as we tend to refer to them, renovate your applications and make them a little bit more portable and give them a little bit more life. For greenfield applications, and these are the pure ASP.NET 5 and .NET Core centric applications, which you may have to develop slightly different because they are now the next generation of applications. For those greenfield apps, again, you can develop within Visual Studio or at the command line across different platforms and readily have those executing almost everywhere. You can push a button, run a script, and deploy them into Docker, either locally or on AWS. And like I said earlier, I touched upon this very briefly, there's nothing also stopping you from being able to bring your applications into a very modern and agile development world. So DevOps is very huge and rapidly going through various organizations, the idea of being able to rapidly develop code and have it shipped into production. So the idea is that you can very much automate from the moment someone builds the code to have it running in the cloud. And if you move your application into AWS, of course you gain the agility that we are so well known for in terms of being able to rapidly provision infrastructure at a very low cost. And for those that need the ability to scale out and cope with very large loads, you certainly get that from our infrastructure. So let's do a hands-on demo and demonstrate how to develop an ASP.NET v5 application on Windows and run that in a Linux container. So what would that look like? Well, before we show the demo, there are going to be two virtual machines that we're going to spin up. We're going to have a Windows server running on EC2 on Amazon with Visual Studio, as well as Docker extensions for Visual Studio, Docker tools. And then we're going to build the application just like we did in the previous demo, except we're going to do it from Visual Studio, same application framework. And then we're going to push a button and deploy it into a Docker container running Mono on Ubuntu. Here you can see my Amazon Web Console for CloudFormation. For this demonstration, we've got a CloudFormation template, as you can see here, that generates two virtual machines. One is a Windows box and one is a Linux machine running Docker. To get this template running, we provided a couple of parameters, such as a T2 medium-sized virtual machines, my key pair, as well as the Amazon machine images for both Windows and Docker, and some additional information about my VPC. It takes about 10 minutes for this CloudFormation template to run. Once it's actually complete, the output parameters you can reference for both the Windows 2012 instance, which we will be RDPing into, the Ubuntu public and private IP addresses for that same machine, which we'll be able to access and remotely run Docker on. Once it's just finally up and running, you will find two virtual machines in your EC2 console demonstrating the Ubuntu and Windows machines up and running with their respective IP addresses. So now that we've deployed the virtual machines in AWS, let's get developing. So here is the RDP'd session into my Windows 2012 server running Visual Studio. So let's kick that off first. This Visual Studio is the Community Edition, along with the installed add-ons for Docker. This can be downloaded from Codeplex and installed over Visual Studio, from which you'll get support for Docker. So here's the traditional login screen. So if we were to start a new project, let's select New Project, click and select an ASP.NET application. Let's call this project .NET on AWS. Click OK. Select the ASP.NET 5 template for web application and click OK. And what this is doing behind the scenes right now is creating a Microsoft Visual Studio template for the classic ASP.NET 5 getting started project. So if we were to click execute, it'll go off and build the project. It's done it pretty quickly. It spun up the local IIS Express web server on a custom port, as you can see here. And behind the scenes, you are running a application in your browser on your local development machine. So that's great, but that's probably not what we wanted. You might do this a couple of times while you're building and developing your application, but let's stop this and let's now have a go at maybe taking this to the next level and then deploying it to our secondary machine, which is an Ubuntu Linux operating system running Docker on it. So the way we actually get this project and then migrate it over to Docker is actually fairly straightforward. So in order to get your application running in a Docker environment, there are a couple of ways you can do that. You can do it from Visual Studio, which I'll show you how to do that shortly, or you can actually do it from the command line. So let me quickly jump into the command line and give you some idea of what that could look like. Now, Microsoft a little while ago, just like AWS, made a commitment to the Docker community. So when you install the Visual Studio extensions for Docker, you end up getting also the Docker command line tool, which essentially looks like this. For those of you who've used the Docker environment on a Linux platform, this is exactly the same experience. You can build images attached to the actual Docker environment, just like you would on Linux. So let's have a closer look at what the environment we currently have that's been set up for us on Ubuntu. So to do that, we need to connect to the remote machine, and that's the IP address that you saw us created via the CloudFormation template. And what this command will give us is it'll list the number of images that have been deployed there. So if we were to go bottom up, the first thing you see is the Microsoft ASP.NET image. Now in this image, we have the .NET runtime environment as produced by Microsoft. The web application 1 and 2 images are the ones that I've been playing around with. There's one that I built 6 hours ago, and there's one that I've also built about 33 minutes ago. So we can also check what is happening on that remote machine by running the PS command. The PS command literally just lists the currently running and executing applications. As you can see, we have nothing running on the remote machine. So let's pop back into Visual Studio and let's take the application we've built and then deploy it over to the remote machine. So this is as simple as essentially right-clicking on your project and clicking Publish. Now there are a number of options here. Now we're going to use the Docker container deployment profile, and we're being asked for some Azure virtual machine records and entries, but we're going to connect to a custom Docker host, which is exactly what we've set up on our Ubuntu machine. So what we need to do is simply provide the endpoint to that Docker machine. So let's go back to the command line. Let's just copy the endpoint, paste it back here, give it the image name. The Docker file will be automatically generated for us, so that's one of the nice perks of working with Visual Studio. Let's select port 80 and port 80 for simplicity, which means this is how we're going to expose the application to the outside world. Let's validate the connection. That's great, we've been able to connect, and let's publish. And what you should be seeing now is we've built the project. It's remotely being executed. So it's being built right now, in fact, not even being executed just yet. What's actually happening is we're actually building the image at the moment. So behind the scenes, Visual Studio is running a whole swag of command line instructions, which is going to take the application we've been building here and push it up to the remote machine. Now it's sending the chunks of the image over bit by bit. It's going through the Docker file. It's making a reference to the other image which contains the Microsoft runtime environment, telling what the entry point is, and finally cranking the application and running it for us. So in a couple of seconds, what we're now seeing is it started up the web browser. So this is the localhost example, which is no longer valid. This will time out because IIS has been destroyed. It's going to time out. So let's forget about that. But here is the IP address of the remote machine. Now this is the machine that's now received my application. It's now running. It's running just as it did on my Windows local development machine here. So to make sure that I'm truly running, I can go back into my command line tools and I can run a PS command. Now what you're seeing is, here is the container ID, here is the web application that I'm running, which has started all of 54 seconds ago. So if we now go back to doing images on it, we will now find that we have the .NET new image that we've just created, which was created about less than a minute ago, and that is the one that is actually running in the browser for us. So this is the actual experience you would have as a developer using Visual Studio and working directly from the AWS environment. Now, having said that, there's nothing stopping you going back to the environment, making changes, and then republishing. Now, what's also interesting about this project is that Visual Studio, when you create these projects, create some custom publishing profiles. So the thing we just set up before, that you saw me setting up earlier on how to connect to the remote machine, it also creates, if we look here, it also creates a bash script. In other words, you could actually rerun and develop this entire application on a non-Microsoft environment, such as using Visual Studio Code, and be able to run this bash command line on a Mac or a Linux environment or any other variant of Linux. And it would actually run the Docker command and also deploy that to that remote machine. Or if you were working on a Windows environment, so here is the PowerShell script. This PowerShell script, again, you could run locally on your machine from a command line. So essentially, if you were to build and integrate this project into the Team City or a continuous integration process that you may have in your organization, you could run these scripts as they are already pre-generated for you to take your application and deploy it into a Docker environment. So I hope this has demonstrated how easy it is to build a ASP.NET application and then deploy it into a Docker environment directly from Visual Studio. And you can do it via the GUI or you can do it via the command line. There are a number of options that are available to you if you'd like to take your .NET applications and have them running inside Docker, and in particular on the AWS cloud. So let's go for a couple of these. Option one would be to roll your own. So this is the selection where you would run Docker on EC2, as we have done in the previous demo. And it's probably something that you may want to do on your local development machine. So there's nothing stopping you from going to Docker and downloading Docker machine and running the Docker locally on your machine as opposed to on a remote box as we showed you previously. Another option that's available to you is to use one of Amazon services such as Elastic Beanstalk. Elastic Beanstalk supports both Docker as well as Windows and IIS. So you can take greenfields, brand new Docker contained applications, or take your legacy applications and deploy them via Beanstalk. And Beanstalk is really a great service for developers who are not particularly too keen about worrying about the underlying infrastructure. What they want to do is to be able to get started quickly with deploying their applications and getting it up and running in the cloud. And finally, option three is for more of the advanced users who potentially would like to use the Amazon EC2 Container Service, or ECS, which supports Docker natively. And what it does is it gives you a great deal of access for your engineers and IT ops teams to be able to have full access to tinker with the underlying core infrastructure that's running your Docker environment. And ECS has a lot of power for things such as scaling out and having the ability to restart and bring back to life any Docker containers that may have stopped or have failed to launch or have potentially crashed. So there are three options that are available to you. Each of these will really vary depending upon your level of interest in tinkering with the underlying infrastructure, such as with ECS, or potentially looking at it from a more higher perspective where you just want to hit a button and deploy your applications, where things like Beanstalk would come in. So in summary, it's really great to see that Microsoft is making cross-platform development and execution easier for the typically Microsoft-centric ecosystem. A lot of .NET developers have been tinkering with Mono and having some varied experiences in that space. Right now with .NET Core and ASP5, that experience is becoming much, much simpler. It's also well documented, which means you can actually follow the guides that are also online to get you started. And for those that are very keen to better understand of what's happening in the runtime, because everything's been open sourced, you are able to go into the Git, check out the particular repo, and be able to look at the runtime or any of the 60 different ASP.NET 5 libraries that you could potentially tinker with and modify yourself. You can take your existing legacy apps that have been built many, many years ago, or build them fresh on the brand new runtime. The options are already there for you. So there's no real restriction on being able to say, I can't run my old legacy application. And by the way, this is only a level 200 presentation. There are other ways where you can actually even take your applications, decompile them and recompile them for new runtimes. It's a fairly advanced topic, but certainly it can be done. And I want you to also remember that AWS here is here to support you on this journey. There are a number of options, there are a number of ways of getting your .NET applications onto AWS. And we have a wonderful team of very friendly solution architects across Australia and New Zealand. So if you need help, please don't be shy, reach out, and we'll be able to come and whiteboard and actually take you through a number of scenarios of how you can actually take your applications to the AWS cloud. So remember, AWS loves Microsoft Windows Server, and we also love Docker, and we have a lot of passionate people who are really looking forward to seeing how this plays out in your cloud journey. So in closing, I'd like to invite you all to the AWS Summit. In fact, we're going to have a level 300 session of this topic delivered. We're going to do a much deeper dive in moving your .NET applications to AWS via Docker. But don't just come for that session, come for a whole bunch of them. We have 2 days worth of presentations from AWS solution architects, as well as some partners. We have boot camps. In total, there's going to be a great deal of sessions, 60 in total. So don't be shy, come and register and come and say hi to the solution architecture team at the Sydney Summit. If you can't wait that long, we also have self-paced training labs. You can also get certified and go through the AWS instructor-led training sessions, as well as listen to other webinars around a great deal of different topics. So in closing, on behalf of myself, Dr. P,
and Daniel Zoltak,
we'd like to thank you for your attention, and we wish you all the very best in moving your classic and emerging ASP.NET applications into the AWS cloud, one container at a time.